Hello and welcome to Decision Support Systems for Managers. We are into Module 5 Decision Support Systems for HR Managers and Lecture 2 of Module 5, that is Employee Selection, Promotion and Deployment Methods. That is, today we will do LP method. Now, these are the concepts covered in this module. Okay, issues in HR, employee selection methods, job promotion methods and employee deployment methods. Okay. Now, issues in HR we have discussed in the previous lecture. Okay. Today, we will deal with employee selection methods. Now, let us spend 1 or 2 minutes on what is employee selection methods. Okay. See, this employee selection methods, normally job interviews, the resumes are selected, then the resumes are shortlisted based on certain criteria. Now, with systems changes, we are also providing points for each criteria, how much marks you have obtained in your class 10, class 12. If you have obtained 100%, you get 10, if you have obtained between 90 and 100, you get 9. So, these different points or weights are given and accordingly we select. Okay. Otherwise, there are lots of questions will be asked. Okay. So, today we will learn some new techniques for employee selection. Okay. Normally, the ones that we follow is simply giving points to the criteria on the basis of which an employee is selected. Today, we will give you some other methods by which you can select employees. Okay. And we will do LP method today. Okay. LP does not mean linear programming, it means linear point. Okay. Now, a company wants to hire employees. I am reading it out. Okay. A company wants to hire employees and has decided to go for newspaper advertisement. 7 prospective candidates have applied. The company has identified 3 criteria for shortlisting the applicants and have asked the candidates themselves to give a score on each of the criteria. I am repeating, a company wants to hire employees and has decided to go for newspaper advertisement. Okay. So, you have advertised, 7 candidates have applied. We are making it a bit less so that it fits in our screen and all that. So, 7 candidates have applied. The company has identified 3 criteria for shortlisting the applicants. Okay. And have asked the candidates themselves to give a score on each of the criteria. Okay. And have asked the candidates themselves to give a score on each of the criteria. The scores given by the candidates to themselves for each of the criteria are given. Okay. So, this is the table. Now, let us spend 2 minutes on this table. We have candidate 1, 2, 3, 4, 5, 6, 7 and we will name them later on as S1, S2, S3, S4, S5, S6, S7. Okay. Now, these informations were asked from the candidate, that is days absent in previous job. This is just an example I am just giving. Okay. We can have many criteria. On target means you have finished the project on schedule, and on target the score is out of 2. So, definitely 2 is better. Number of days taken to complete project worth rupees 100 crore. So, this is the number of days taken. Again, these are just arbitrary numbers, do not take it at their face value. Okay. So, number of days taken to complete project worth rupees 100 crores. So, candidate 1, in the previous job in 1 year he was absent for 50 days. He was on target for all his work 0.95, that means almost 50%, almost 47% of the times he was on target. Number of days taken to complete the project worth rupees 100 crore is 105650. It is a number, actually we will make it less. Okay. So, last candidate, candidate 7, in the number of days absent in the previous job, he was 65 days in a year he was absent. On target he was 1.33 times. The number of days taken to complete the project worth rupees 100 crore is 6200. Now, you will ask me the projects may be different. Yes, but here we assume that the projects of similar type. Okay. But this is just as I said for demonstration purpose. Okay. Nothing I mean sacrosanct. So, you see what we are seeing from this table, just have a look at this table. What you are seeing from this table, let us see. We are noticing that each one is good in something, then the other not good in something. Okay. So, these types of things are there, good in something, not good at something. So, it is bit difficult to come up with a conclusion on basically what to do, which candidate to choose, okay, and assume there is no interview, it is only the data, and all this data that they have given is backed by basically you are shortlisting them right now, okay, then they might be called for interview. Okay. So, shortlisting them. So, each of this information that the candidates have furnished is backed by documents. Okay. So, given this, what will you do? You see different things, one this one is good, other that one is bad. If you see candidate 5, number of days absent is 40 only, very good, but on target is 1.17, but the best candidate on target is candidate 6, but his days absent is 60. Okay. So, a lot of these conflicting things are there. So, we will have to be very careful on arriving at a solution. Okay. Yeah. Now, so how to do it? Looking at the data, we find that for 2 of the criteria, days absent in previous job and number of days taken to complete project worth rupees 100 crore, our objective is minimize. Let us see what it means. Yeah. See, days absent in previous job, as a HR person, do you want a candidate who is absent very much or less absent? You want less absent, right? A candidate who is more absent, you do not want him or her, less absent you want. Okay. So, days absent in previous job, your objective is what? Your objective is to minimize, right. So, min, right. Your objective is to minimize. So, days absent previous job, min. Okay. On target, what is your objective? Your objective is to maximize, right. Your objective is to maximize, because you want on target. Number of days taken to complete project worth rupees 100 crore. Okay. Number of days taken to complete project worth rupees 100 crore. Again, what is your objective? Minimization, right. You want to minimize the number of days taken to complete, right. So, days absent in previous job, minimize, on target, maximize, and number of days taken to complete projects, minimize. Okay. So, you see 3 conflicting objectives, rather 2, min, max and min. Okay. So, how to proceed? Okay. This is what we have already mentioned. Looking at the data, we find that for 2 of the criteria, objective is minimize, for 1 it is maximize. Hence, we need to normalize the data first. Let us bring all of them to a common platform. Formulas to be used for normalization. For min, H j minus F I j divided by R j. Okay. What is this R j? Is that is highest minus lowest. Now, I will explain this. For max, F I j minus L j by H j minus L j. Okay. What are these basically? I will explain. H j is the highest value in that particular column. F I j is the value at that particular cell. Okay. H j highest value in that column, F I j is the value at that particular cell, and H j minus L j is basically the range, that is the range of that series. So, let us go back and see what this is. Let us take days absent in previous job. Okay. Days absent. What is the criteria? We have to minimize, right. What is the minimization formula? H j minus F j divided by H j minus L j. Okay. So, we have got 3 terms H, F and L. Okay. So, what is Hj? Highest value in that column. So, let us look at this column, days absent in previous job. What is the highest value in that column? 80. What is Lj? Lj is the lowest value in that column, that is 40, right. So, go back to the formula once again, Hj minus Lj in denominator. So, what is the value? 80 minus 40. So, 40 is the value of the denominator, okay. And H top, let us see the numerator, Hj minus Fij, okay. Go back to this candidate 1, Fij is the value, candidate 1, Fij is the value at that cell. So, what is the value at that cell? 50, 50. So, Hij minus Fij will be, Hij was what? Highest value, right? Hj, that is 80. 80 minus Fij, Fij means the value at that cell. So, 80 minus 50, it is 30. Okay. So, what is what does the minimization formula look like now? Hij minus, sorry, Hj minus Fij, that is H is 80, Fij is 50. So, 80 minus 50 is 30 divided by Hj minus Lj, which is 80 minus 40, 40. So, 30 by 40, that is equal to 3 by 4, that is equal to 0.75. Okay. This is for the first cell. So, 0.75. So, see this column, candidate 1 is 0.75. Okay. For the next one, 80. Okay. So, 80, highest value is again 80, next cell, candidate 2, that is row 2. Okay. Now, highest value is 80, right, highest value is 80. What is the cell value? Cell value is also 80. So, 80 minus 80 is 0, and what is the range? Bottom, Hj minus Lj, 40, right, 80 minus 40, that is 40. So, 80 minus 80, that is 0, Hj minus Fij, 80 minus 80 is 40, sorry 0, 0 by 40 is 0. Okay. So, let us see candidate to 0.00. So, in this way we will normalize, okay. We will normalize this entire table, okay. Clear? Let us take the second one, the criteria maximize, okay. Yeah, on target out of 2, 0.95. What is the maximize formula? Fij minus Lj by range. Okay, Fij minus Lj, that is the next one, Fij minus Lj divided by Hj minus Lj. Okay. Yeah. So, let us create this same table. Okay. Candidate 1, column 2, on target. Fij is what? 0.95 minus Lj. Lj is what? The lowest value. Lowest value is what? 0.83. So, 0.95 minus 0.83 divided by, what is the range? Range is 1.33 minus 0.83. Okay. Highest value minus lowest value, 1.33 minus 0.83. Okay. So, that value will come to 0.10. Okay. So, in this way you prepare this entire table. This is called as the normalized matrix. Now, deducting each value, actually this is a bit reverse, deducting 1 from each value, deducting 1 from each value. So, basically 0.75 minus 1 is minus 0.25. Now, what is this 1? Deducting 1 from each value. What is this 1? This 1 is the ideal value. Okay. This one is the ideal value, that you will have to remember. So, deducting 1 from each value, we get this table. Okay. Square the values, fine, we have squared the values, just a second. So, we have squared the values, okay. And then add the candidate scores. After you have squared the values, add the candidate scores, that is 0.05, 0.81, 0.44. Add the scores, you get 1.3. Okay. square them, 1.3 square, then square root, that is 1.30. Okay. So, what do we do? Add the candidate scores, square them and then do a square root. Okay. Now, once you have done this square root, you arrange them in descending order, that is smallest to in ascending order, that is smallest to highest. Okay. Now, why smallest to highest? You see, rank smallest to highest. Why smallest to highest? You see, what is happening here is that what are you measuring? Actually, when you are squaring a square root, you are measuring the Euclidean distance. Okay. Euclidean distance, your ideal value is 1. Okay. Your ideal value is 1. When your ideal value is 1, this one, how far you are from the ideal value? How far you are from the ideal value? So, the closer you are to the ideal value, that is better. So, the lowest score is better. 1 is the ideal value. So, the closer you are to 1, it is better. So, the lowest score, that is the lowest difference between 1 and this point, the difference between the distance between 1 and this point, the lowest distance is the best score. Okay. And we have just calculated the distance using the Euclidean formula, okay, square and square root formula. The lowest distance is the ideal score. Okay. So, square root. So, rank, the lowest one will be the ideal score. I repeat, why is it ideal score the lowest one? Because your ideal score is 1 and you are measuring how far you are from 1. So, the one which is closest to 1, that is best. Okay. And so, that means what? The distance minimum, the minimum one with the minimum distance, that is the best. Okay. So, here the minimum distance in the square root column, you check up last third from the last square root column, the minimal distance one is basically 0.38, that is that is the employee 6, and here you candidate 6. At the last column you will see candidate S6. Okay. So, this candidate is rank number 1. The next one is 0.52, the next immediately closest distance 0.3 is candidate number 2. Third one is candidate number 7. Okay. So, 0.64. So, the first candidate is S6, second candidate is S5, third candidate is S7. So, in this order. Now, what is the benefit of this method? The benefit of this method is you have brought out. So, this is the rank of the candidates. Okay. Rank 1, 2, 3, 4 is candidate 6, 5, 7 and 2. What is the benefit of this method? The benefit of this method is you have brought the entire information under one umbrella, given it a mathematical meaning, and you have taken a logical decision based on that mathematical meaning. So, no one can question you tomorrow as to why this has happened. There was some impropriety, there was some nepotism. No one can tell all these things to you. Okay. Candidates have given them some score, there are documents available to verify them, and you have done some method to select these candidates. Only thing is, these 3 criteria that we have mentioned, let us say days absent in previous job, on target, number of days taken to complete a project. These 3 criteria here we are giving equal weightage, okay. But some organizations may give more weightage to some criteria. Okay. So, that we will do in the next lecture. Okay. So, but that part is separate, but the basic methodology will remain same, basic methodology will remain same. Okay. So, you square the values, and so these 3 criteria we have taken for this. Now, if you have more candidates, just increase the number of columns. If you have more criteria, just increase the number of rows, nothing else, but the basic calculation methodology will remain the same. Here we took 3 criteria, calculation methodology we used was LP norm. Okay. Clear? So, this is one method for employee selection. Other methods for employee selection will be rating, Borda, okay, and we will proceed. Now, these methods are also called as multi-criteria decision making methods. Okay. clear, where there are so many criteria and you will have to take decision based on optimizing of these criteria. Okay, clear. So we deal with lot of assigning weights etc. for selection of candidates. Here through this method we learned one more way of selecting candidates. Okay, this will cater to your semi structured way of doing interviews, okay, for selection of candidates, because you see the criteria are a bit different. Okay. Okay, sorry, yeah, that slide is not here. Now, why as I have explained, why did we rank the candidate with lowest square root as rank 1 candidate? The idea is to minimize the distance from the ideal point. The ideal point is 1. Okay. Now, there is a small typographic error. I will just calculate, this slide has to be deleted. Yeah, we have already this one, right? Yeah, the ideal point is 1. Okay. Clear. Now, the other two methods we will discuss in the next lecture. Okay. Clear. This is the references. Now, this book I do not the Wiley is the publishers, multi-criteria decision making, Ishizaka A and Nemeri P. This has some of these methods. Remember, these methods are not sacrosanct in the sense that it is only applicable to HR. Any decision making problem where there are too many criteria to choose from, which we call as multi-criteria, any such decision making problem, some multi-criteria decision making problems, this book will be very good. Okay. Yeah. So, thank you for today. We will take on with next lecture in the next class.